All right, today we're going to go ahead and start chapter 7. All right, we're going to start off with section 7.1 and we're going to start looking at trig functions. All right, so in this chapter we'll start using trig functions to eventually solve for missing sides or angles of a right triangle with certain angles in it. All right, so today is going to be our focus to understand the trig functions and what the 6 functions are and how we find their angle relationships in triangles. So here we go. The first thing we're going to look at is the definition of trigonometry. All right, a branch of mathematics concerned with angle relationships inside triangles. All right, so here's how we're going to do this is we're first going to go ahead and list the 6 functions and then we'll talk about them. And then we'll look at how we're going to use these to identify ratios from a triangle today. So our first function is what we call the sine function. All right, the sine function is abbreviated on a calculator. If you were to look, it would say, it looks like it says sin. All right, sine is our first trig function, and we look at it as sine, S-I-N, on a calculator. Our second trig function is called cosine. All right, cosine is also a function that's on a calculator, and its abbreviation is COS for cos. The third function is tangent. All right, and when we abbreviate tangent, we use tan. Now, these first 3 are the big 3 that we are always going to use to solve, and we're going to use them to get us started. All right, the sine, cos, and tan are the abbreviations that we see on our calculator. Now, let's go ahead and list the fourth function. The fourth function is called cosecant. Cosecant. All right, the abbreviation for cosecant is CSC. All right, the fifth function that we have is called secant, and we abbreviate that with SEC. All right, our last function then is what we call cotangent. And our abbreviation is COT. All right, so our 6 functions are listed on the left-hand side with their abbreviation on the right-hand side. Sine, cosine, tangent, cosecant, secant, and cotangent. These are the 6 functions that we'll use for trig. Notice the star next to the 3 that are going to be the most important throughout this chapter. All right, so let's go ahead and continue by looking at the 3 most commonly used functions in the picture. So here's how this works. Let's say we have cosine A, or angle A. So let's put a dot in our picture by angle A and say they want us to do everything based on angle A. Well, the way this works is sine of an angle is technically the opposite side over the hypotenuse. All right, so for sine, we're going to think of sine as being, well, we'll show that in a minute, O over H. All right, O stands for opposite, H stands for hypotenuse. All right, now let's go back to the next one, and let's look at what cosine stands for. Cosine stands for adjacent over hypotenuse. All right, so we are going to think of cosine as cos equals A over H. Adjacent over hypotenuse. All right, now let's go back and let's look at what tan, how are we going to remember tan? Well, tan is going to be the opposite side over the adjacent side. All right, so when we go to write a tangent, we're going to think of O over A. All right, so let's say that we're looking at that picture of the triangle they gave us. Okay, and let's say that they ask us to come up with the fraction for sine, come up with the fraction for cosine, and come up with the fraction for tangent. Here's how this works. They will give us an angle to start at. So let's say they said angle A to start at. So let's put a dot by A. What we're going to do is we're going to label our sides to come up with the ratios that should take place based on the function. Now, when you go to label your sides, you typically want to stay with a pattern. Start at the angle they give us. So if they say angle A, I'm starting by the purple dot in the triangle. I'm going to go to the side across from it right away, and I'm going to call it opposite. It's the side that's opposite. Notice it starts with an O, so I'm going to think of that as being side O. Next, I'm going to label my hypotenuse, and we know the hypotenuse is always across from the 90. So I'm going to call this hyp, which is technically letter H. Well, what that does is that means that the last side has to be the adjacent side. So I'm going to call the last side ADJ, which is adjacent. Now, we're going to use the letters from our picture to write the fractions for each one. Sine says opposite over hypotenuse. So you'll notice letter A was on the opposite, and you'll notice letter C is on the hypotenuse. So the sine of angle A would be A over C. If I was finding the cosine of angle A, well, this time I want adjacent over hypotenuse. So if you look at your picture, on the adjacent side was the letter B, on the hypotenuse was C. Well, if it wants us to find tangent of angle A, well, tangent is O over A, opposite over adjacent. You'll notice on the opposite side had letter A, on the adjacent side had letter B. All right, so we're going to use these little abbreviations to remember how do we set up sine, cos, and tangent, which eventually we'll get to solving with those. All right, so how are we going to remember this? Well, the way we remember this is so, ka, to, and some people like to write it this way. Other people will write it like this. I will show both. Let's show this first. What this stands for is the S stands for sine of the angle. Notice O was first, H is second. So to find sine, I'm going to do sine of the angle equals opposite side over hypotenuse. The cos would be the C, cos of an angle, should equal the adjacent side over the hypotenuse side. And then the T stands for tangent of an angle, and then notice it has an O and an A. O stands for the opposite side on top, adjacent on the bottom. Now, this is one way that you can think about it to remember. The other way that you can think about it to remember is I've seen kids look at it like this. Sine is O over H, so ka, C, cosine would be A over H. Tangent would be opposite over adjacent. All right, so another way you can remember it is so, ka, toa. So stands for sine, opposite over hypotenuse. Ka, C-A-H, cosine, adjacent over hypotenuse. And then the last one, tangent, opposite side over adjacent. All right, so let's go ahead and use that to come up with some examples. Before we do that, let's look at how we're going to approach this. All right, this looks like a lot of gibberish to me. It says the reciprocals and all this of the first three functions will create our other three functions. So what we want to do is we want to think of like a reciprocal slash inverse. It's flipped. So the way this works all right, and I'm going to squeeze it in over here, is that, remember, sine is technically opposite over hypotenuse. Well, what happens is cosecant is just it flipped. It's the reciprocal. So if it asks us to find cosecant, we're going to take whatever sine was, and we're going to flip it to put the hypotenuse on top and the opposite side on the bottom. All right, well, the second case right here, what this explains is that cos is originally adjacent over hypotenuse. If they ask us to find the secant, it's the opposite of cos. It's flipped. The hypotenuse is on top, the adjacent is on the bottom. So we flip our fraction. All right, well, the case 3 says, well, if tan is TOA, opposite over adjacent, to find the cotangent, we can flip it and change it. So the cotangent would be to flip the fraction and put adjacent on top, opposite on bottom. All right, so we tell kids to try to find the sine, cos, and tan first, and then go back and flip it over to find the missing one. All right, let's go ahead and look at an example and see how we're doing. Sine will flip to cosecant, cos will flip to secant, tan will flip to cotan. All right, so here we go. Let's show you what we're talking about. They're going to ask us to find the 6 functions. So they want us to find sine, cos, tangent, cosecant, secant, cotangent. You'll notice they give us an angle theta, so this is our starting point. So I'm going to put a little star up here. This is where I need to start to label my sides before I begin the problem. All right, now, here we go. I'm going to label my sides, so I'm going to go straight across, and I'm going to call that side the opposite. Remember, opposite is technically side O. Next, I'm going to always go across from my 90, because I know across from 90 is always the hypotenuse, which I'm going to call H. That means the last side has to be the adjacent, which is A. Now, I would encourage you to stay with that order when you label them, because the adjacent usually gives kids the most difficulty. Now, let's just think from back to the last page. So, ka, toa. I'm going to go ahead and list sine, cosine, tangent first, and then I'm going to flip them to come up with cosecant, secant, and cotangent. Well, sine of that theta angle should technically be opposite first, so opposite had 4, hypotenuse second, hypotenuse had a 5 on it. I'm going to do my cosine second. Cosine of that theta angle says I need adjacent side first. Adjacent has a 3. Hypotenuse was a 5. My fractions are all reduced, so I don't have to worry about anything right now. Now, let's go ahead and list our last function, tangent of our big 3, tangent of theta. That equals opposite over adjacent. So opposite was 4. Adjacent was 3. So we use our SOHCAHTOA to help us set up our fractions. Now, remember, to come up with the other 3, we want to go ahead and find the cosecant next. Well, if sine was 4 over 5, cosecant means it's flipped. It's 5 over 4. All right, well, if cosine is 3 over 5, then secant, which is the reciprocal of cosine, would be flip your fraction, 5 over 3. If tangent of theta was 4 over 3, then cotangent would be the reciprocal, flip it, 3 over 4. Our 6 answers, or 6 functions, are inside this box. Again, we encourage you to try to do sine, cosine, tangent first, and then go back and flip them in order to find cosecant, secant, and cotangent. Notice which ones go together. I kept them in the same color. All right, let's do another example of that, and then let's look at how can I change that. Example 2 is very similar to example 1, except this time they moved our angle on us, and they put our angle down here in the corner where I'm going to put my star. Now, before I try to list my 6 functions, I'm going to label my sides. I'm going to start from that angle. I'm going to go across to the opposite side and call it O opposite. I'm going to go across from 90 and I'm going to call it the hypotenuse H, which makes this side the adjacent. Again, that's usually the harder one, so try to stay in that order to label your picture. Now, before we get started, let's just think of our little cheat sheet. We have so, ka, toa. All right, we're going to go ahead and list those first. So let's do sine first, and then we'll come back and we'll flip them. So sine of theta is equal to, I need opposite first, so 8 on top. I need hypotenuse second, so 17 on bottom. Let's do cos of theta. Cos would be adjacent, so 15 on top. Hypotenuse was 17. It can't be reduced, so we're good there. And our last one, let's go ahead and do tangent. Tan of theta is equal to opposite over adjacent. So I listed our big 3 first. Now, go back and come up with your other 3 functions. Remember, cosecant is the reciprocal, or it flipped. Remember, secant is the reciprocal of cosine, so let's flip it. And then last, remember, cotangent is the reciprocal, so let's flip it. We now have listed the 6 trig functions for this picture. All right, today we're just trying to list the functions. We'll eventually look at how we're going to solve these. All right, let's go to another example and let's look at how can I give you this from just a word problem. All right, so notice it does not give us a picture, and it only tells us this little piece of info right here, that's sine 12 over 13. So we want to think about this in relationship to a triangle. Now, think about our cheat sheet. So, ka, toa. And let's make sure that one looked like an H. It's kind of sloppy. There we go. Okay, so this is our trig function. Now, let's think about what sine they gave us. Sine is 2 sides. It's opposite over hypotenuse. Well, I can pick an angle any of these 2 other spots. So let's say I threw our theta down here. I threw our angle down there. Now, I want to label my sides and then figure out where am I going to put the 12 and the 13. So if I went across, this side would have been opposite. If I went across from this side would have been my hypotenuse. If I went to this side, this would be my adjacent. Well, you'll notice they told us 12 over 13, and 12 is technically the opposite, so I'm going to put 12 on the opposite side. I'm going to put 13 on the hypotenuse. You'll notice I'm missing this bottom side. So I'm going to do some side work first. I'm going to do the Pythagorean theorem to find that missing side. So I know that 13 is the c, so I'm going to do x squared for that missing side plus 12 squared, my other leg, is equal to 13 squared, the hypotenuse squared. That turns into x squared plus 144 equals 169. Let's continue to solve it by subtracting 144, and I'm left with x squared equals 25. Square root it, and I get x to equal 5, so I know that this missing side is 5. Now, we're all set to go ahead and answer the questions. It wants us to list all 6 functions. Well, we know sine was 12 over 13 because they gave us that one. We know that cosine should be adjacent over hypotenuse. Adjacent is 5, hypotenuse is 13. We know that tangent of theta is opposite over adjacent, so 12 over 5. Now, after we get our first big 3, let's go back and find our other 3. Cosecant is sine flipped. So let's flip 13 and 12 to a new spot. Well, secant is cosine flipped. So let's flip 13 and 5. And then last, cotangent should be the tangent flipped. So let's flip it and call it 5 over 12. Our final answer are inside the highlighted box, our 6 functions. All right, so that's considered one of the more difficult ones because we have to do Pythagorean theorem first. Let's look at one more of those examples. I'm given a word problem and they give us the function cos. All right, and then we're going to go ahead and try to fill in some missing pieces from there. Okay? All right, here we go. I'm going to go ahead and draw myself a triangle and try to come up with the sides of the triangle. Remember our little cheat sheets, so, ka, toa. Now notice they gave us cosine, and we know that cosine is adjacent over hypotenuse. So let's label our sides. Across from there is opposite. Across from 90 is always the hypotenuse, which makes the last side the adjacent. Notice this time they gave us cosine. They gave us 40 in the spot of A, so I'm going to put 40 on the adjacent side. They put 41 in the spot where my H would have been, so I'm going to put 41 on the H. You'll notice I'm missing a side again on my triangle, so I have to do some Pythagorean theorem first. I'm going to call it x squared plus 40 squared is equal to 41 squared. Well, that turns into x squared plus 1600 equals 1681. Subtract 1600. And I'm left with x squared is equal to 81. Square root, and x is 9, so I'm going to put 9 back into my picture. Now, that was just some side work to find the missing piece for our triangle. Let's go back and let's list our sine. Remember, sine is opposite over hypotenuse, so 9 was on opposite. 41 was on hypotenuse. Let's list cosine. Cosine says adjacent first, so 40 over hypotenuse, 41. All right, then let's just list the tan. Tan of theta says opposite, so 9 over adjacent, 40. And now let's go back and let's flip them. To find our cosecant of theta, I'm going to flip my fraction, 41 over 9. To find my secant, I'm going to flip cosine, so it's going to be 41 over 40. To find cotangent, I'm going to take tangent and flip it and put 40 over 9. Inside the purple highlighted box to the right are our 6 functions for trig. All right, let's go ahead and do another example. Example 5 is going to be your most challenging, and they're going to try to trick us here. You'll notice they give us a function but not a picture, so we're going to have to find the missing piece of our triangle. All right, I threw my theta over in the corner, so I'm going to call this side opposite, straight across. I'm going to call this side my hypotenuse, straight across from 90, which makes this side the adjacent. Let's go ahead and write down our little cheat sheets. So, ka, toa. All right. Now, this one's going to be a little more challenging for us. Couple things to think about here is they're giving us a secant this time. So they're giving us a secant, which isn't one of our normal sine, cos, or tan original big three. So we need to think about what secant goes to. So, for example, think of it this way. Secant is technically 25 over 7 right now. Well, if you think back to the last couple of examples, secant was technically the opposite of cos. All right, so if I wanted to, I can convert this to cos by saying cos 7 over 25, it's the reciprocal. I'm going to use this cos to label my picture because I know that cos is A over H. Well, if it's A over H, we know that A should be 7, the adjacent, and H should be 25. Well, we now have to go ahead and do Pythagorean theorem to find the missing piece. 25 is the hypotenuse, so I'm going to do x squared plus 7 squared is equal to 25 squared. Convert those to numbers, I get x squared plus 49 is equal to 625. Subtract 49 over, and I'm left with x squared equals 576. Square root it, and I get x to equal 24. All right, so my x is 24 for my missing side. Now, let's go back and label all our sides then. Well, we know sine of theta is opposite over hypotenuse, so 24 over 25. Remember, our cos is adjacent over hypotenuse, so 7 over 25. My tangent is opposite over adjacent, so opposite was 24 over 7. Remember, to find the other ones, we're going to flip the fraction. So cosecant would be 25 over 24. Well, secant would be, flip your fraction, 25 over 7. And then your last one, cotangent, would be to go ahead and flip this and call it 7 over 24. The pink highlighted box are our 6 trig functions. All right, let's go ahead and do one more. And we'll see how it goes. And then we'll go from there, and we want to show you what happens when it doesn't turn out as pretty. All right, so we've got our word problem again. It tells us that tan is 6 over 7. All right, I'm going to go ahead and set up my picture. I know across from the angle we start at is always opposite, so O. I know the one across from 90 is hypotenuse always, which makes this other missing side the adjacent. I'm going to put my little cheat sheet up here, so ka, toa. Now, notice they're giving us tan over here. All right, they're giving us the tan, and we got to think, what is tan? Well, tan, if I use my little cheat sheet over here, is opposite over adjacent. So right now I know that the opposite side should be 6, the adjacent side should be 7. Notice I'm missing the hypotenuse this time, so we're going to do some side work first. We're going to go ahead and do the Pythagorean theorem on the side first. So 6 squared plus 7 squared should equal x squared. Well, that's 36 plus 49 equals x squared, and 36 plus 49 gives us 85. Now, you'll notice those last examples we did, this always turned out to be a perfect square root here. All right, if it's not a perfect square root, then just leave it as square root of whatever you get. So I'm going to leave it as square root of 85, and I'm going to go back and put it into my picture. If you went to the nearest decimal, that would be fine too. We'd also accept it. Now, once we have all three sides of our picture, let's go ahead and start to write down our 6 functions. Sine of theta is opposite over hypotenuse. So opposite had a 6, hypotenuse had square root of 85. For cosine, I want adjacent first, so 7, and then hypotenuse second, so square root of 85 on the bottom. Third, I want the tangent. Tangent says opposite over adjacent, so I need opposite first, adjacent second. After we list our big 3, let's go back and let's list the other 3. So cosecant would be it flipped, so square root of 85 over 6. Well, secant would be it flipped, so square root of 85 over 7. And then the last one, cotangent of theta, would be its opposite, so flip it, 7 over 6. All right, we now have all the functions inside the brown highlighted area. All right, so you'll notice sine goes to cosecant, cos goes to secant, tan goes to cotan. All right, if we can get the first 3, sine, cos, and tan, we just have to be able to flip them to get to the ones that we need next. All right, we'll do a little bit of practice of this, and then eventually we'll look how to solve in this chapter using sine, cos, and tan.